No.
Alrighty.
All right.
Presentation. Thank you.
Thank you. All right. So in the coming presentation, I will be covering the hardware solution requirements for the distributed edge data centers. My name is Mikko, Ohvo, coming from the Nokia A-frame organization, and working there as a business development manager for the airframe designs. So as said, what we are seeing in the OCP forum is a great collaboration in terms of the traditional hyperscale type of deployment scenarios for the servers, storage, and racks. However, we believe that this form factor may not be the optimal for addressing the needs in the highly distributed edge data centers, which are by nature completely different in terms of the facility requirements and as well in terms of the application requirements. So as said, the centralized data centers, the upper half within the slide, this is well addressed by the IT hardware that we are deploying on a daily basis in the centralized data centers. And then the need in those is to have the efficient scalability, really robust performance, and automated operations to enable easy scaling of the hardware capacity required for the various applications. However, in the distributed data centers, the key demand is to drive down the latency. And to be specific on that, the radio and mobile edge computing apps are driving for the extreme latency requirements. In the 4G, we have been talking about 10 milliseconds round trip. In the coming 4G evolutions, we are now implementing 5 to 2 milliseconds round trips on the services, and in the 5G, we are going below 1 millisecond. And those are driven by the requirements on the applications that we plan to have on the networks to support our daily activities. So the way how we are addressing this is seeing different kind of tiers in the data centers. The centralized data centers on the right-hand side of the slide. This is with a few sites with rather high power budgets, and the physical dimensions of the servers and the racks can be basically whatever required by the hardware itself. Whereas then in the regional data centers, where we are talking still about a few tens of sites in the networks, there are already limitations in the power budgets and as well what kind of dimensions we would be able to support in the deployments. Then going to the extreme left on the slide, the local data centers. There the demand is for hundreds of different sites with rather low power budget. Typically we are seeing numbers below 4 or 6 kilowatts per rack. And then rather tight limitations on the physical dimensions of the servers and as well the racks. So this kind of tiered approach is what we believe is illustrating best where we are in terms of the requirements for the mobile edge or the distributed edge data centers. So how we can then address these with the open rack? It's obvious that for the central data centers. All right, there's a problem with that one. It doesn't sync up.
Drop your
Is it coming?
Unplug it all the way.
Yeah.
Give it a couple seconds. Oh yeah, it's unplugged, so it's.
It's on the cable itself, I believe, not on the.
Hold on a second then. Sorry.
No worries. I believe this would be a perfect moment for the questions and answers, but a bit premature still on the presentation. Apologies for the hassle with the hardware. And this is, by the way, why the telco hardware always comes with the full redundancy. This one I believe is the IT gear. I'm a telco guy, as you can tell. Apologies for the bad joke on the on the IT. So it would be a scale out option in the IT side. There would be redundant sites covering this one. In the telco, it would be this one laptop carrying the redundancy. So there is a redundancy.
Hold on a second.
Yeah.
Go ahead.
Thank you.
Insert. Bring it up as soon as you.
Sure. So up and running. Let's see whether it lasts. So what I was saying is that with the existing OpenRack version 2 deployments, we can easily address the central data centers and the needs within those. And typically what we are seeing in these central data centers, it's either the AC powered equipment on the deployments, or high voltage DC with the 400 volt DC power feeds within the facility. Our solution is supporting both options. On the regional data centers, we are coming up with the play with the minus 48 volt DC power distributions, supporting the sites with the old legacy telco gear, typically having the minus 48 volt DC feeds supported. And in these, we are to a large extent able to deploy the OpenRack version 2. Still with some power limitations. Typically we are able to span all the way to 10, 12 kilowatts per rack, not higher than that on typical conditions. Then on the edge data centers, there the physical limitations on the site are kicking in to the play. We are seeing demand for having really limited depth of the servers, something like 600 to 800 millimeters, not the full scale OpenRack with more than 1,000 millimeters. Then the I/O intensive applications are requiring different kind of implementation on the servers. Typically that would be going with the single socket designs. And this would be then optimal for any application, including the virtualized RAN running on the edge of the networks. So why do we need different kind of server hardware? As said, the mainstream servers are typically general purpose, and they are based on the dual socket designs. As we heard in the earlier presentation from my colleague, we have a NUMA optimized design there, but then the hardware cost of performance with the dual socket design for this kind of application is quite easily driving the cost higher than can be tolerated in the limited edge design implementations. And as said, one of the key drivers there is the physical size of the gear. So what are the key requirements then? To remove the NUMA problem, easiest way to overcome that is to use a single socket design. Then to have a compact and fault-tolerant design. All the telco requirements are typically on the edge. Thermal requirements, seismic zone force support, different kind of humidity and ambient temperature requirements on the edge deployments, which are not there in the hyperscale data centers where the Open Rack version 2 typically is being deployed. And of course, as always, it has to be a cost-optimized, a vanity-free design, as obvious. And it has to be having the flexibility for supporting different kind of use cases, starting from the network function virtualization, spanning all the way to the content delivery requirements or mobile edge computing requirements. And last but not least, is to have the capabilities for running hardware acceleration on the same hardware. So as a summary, what we are proposing is to come up with the design principles for a new hardware form factor supporting these far edge or edge data center requirements. It has to be fitting to a limited depth of the racks. It has to be NEPS compliant. Front serviceability would be allowing ease of operations and providing the operational excellence. High performance, meaning different kind of SKUs to be supported per the application requirements, with rather high density as the physical space on the data centers is limited, and to have high efficiency in terms of the TCO, meaning that the power utilization is a key in the designs. And of course has to be providing the I/O capabilities required for the edge data centers to be able to run the I/O intensive applications. So with this, I would complete my presentation. Welcome to visit Nokia at booth B6, and it would be time for questions. Yeah, please.
How critical is NEPS still, especially in the mobile network?
What we are seeing from our customer base is still the same kind of demand for NEBs. Not the full set of NEBs, but more some specific areas of that. For example, the seismic zone force support is still a rather strict requirement in certain regions.
Even in mobile networks?
Even in mobile networks, or especially in those. All right, if no other questions, then thank you for your time.
Okay, thank you, Mikko.